Dear students, this is Professor N. Venkatachalapathi, Institute of Aeronautical Engineering. As this course manufacturing process consisting of the 5 major units in that metal casting process, fabrication process, and what important thing is metal forming or mechanical working of metals, additive manufacturing, and some forging process. So especially the student think that manufacturing process is always it is a theoretical subject. So we will focus on only theoretical diagrammatic principle and concept or advantages applications. But really when you wanted to test competitive examinations like GATE, IES, and some of the competitive examinations, even NP, some central government jobs also, they will ask basic fundamental formulae which is related to manufacturing process, even the metal casting, some welding, and even metal forming like forging and some bending and some of the what you call piercing and blanking operation, not for a theoretical analytics, but you have to have some of the formulas which is related to this metal forming or mechanical working of metals. So this may be useful for attempting in gate examinations. Nowadays the student wanted to have a higher studies in especially in IITs and NITs. He or she should get to more than some nine 9 percentile, above 90 percentile. He has to focus on some important formulae which is related to manufacturing. Always some textbook only they can focus on theoretical background only. So when you wanted to have some problematic formula related discussion for the manufacturing processes, the Goshen Malik, one of the most important, Goshen Malik, IT Kanpur professor, he has written the textbook, and in that lot of some example and exercise problems also available. In that, if you focus some basic concept and how you can apply that knowledge into solving the different type of problems. So before going to discuss about this metal forming, especially forging, what are the force to be calculated in the forging and all, we'll discuss in detail in this slides. Okay. Now let us see the generally, as you know that forging already I have given a clear discussion about the previous videos about the what is forging, different type of forging. There is open die forging, closed die forging, etc. Apart from that, now let us see just a couple of minutes just to focus on the concept of this forging. Forging is a manufacturing process where it involves shaping the metal using localized compressive force. You can observe this 3D diagram. You can observe the 3D diagram, three-dimensional diagram, 3D diagram of forging. Okay, so here this is the workpiece, how they can hold. It is a red hotted temperature. The temperature is about 1400 degrees centigrade. A human cannot handle such type of thing. Even a one teeny size component fell on the skin and all, it may be some melted like anything. So that is why here some automated and fully automated and somewhere for handling the this hot metal, there is a highly skilled people are required to do these things. Okay, so that is why here the blows are delivered with a hammer, often the power hammer or a die. And this forging is often classified into according to temperature at which it is performed. Below recrystallization, we'll call it as a cold working. Above its recrystallization, that is what a metal can be heated to above its for example, mild steel, if you take it more than 923 degrees centigrade, you can heat it and it will become red hotted. Then you can able to transfer and you can apply some force and pressure, some not manually, some automatic presses, high tonnage presses to be used to form its shape, circular into a rectangle, rectangle into a some polygonal shape, etc. So this is all so many some what you call some spanners type, wrench type, and some bolt and nut type of components can be easily performed in this case. Okay, and for the latter two, the metal is heated usually to a forge. Forged parts can range in weight from less than a kilogram to 100 of metric tons. Even a not only tiny size, very high capacity, more than 1000 ton and 2000 ton capacity of the presses to be used to form with the shape by applying the compressive force. So with this basic concept, and what are the important parameters required. So first you have to heat it, and how much pressure, force, and what is the weight of the component, length, width, and thickness. These three parameters plays an important role in order to determine the forging force and forging pressure for the area of the given component and all. That we'll discuss in the problems clearly. So look at this is one problem they may ask it in the gate examination. So the problem is simple. Only thing is if you know this formula, so this is the forging force. F can be determined by with a simple formula like sigma t. Sigma t means the what is called that shear stress into area. Shear stress into area, that pi by 4 d square into some constant parameter 1 plus mu d divided by 3h. So let us see the where that sigma F is the flow stress of the material. This is here not SF, sigma F. Sigma F may be the flow stress of the material, where mu is the coefficient of friction, and D and H are, that is D means the diameter of the workpiece, H is the height of the workpiece respectively. So all these parameters are very very important in order to determine the forging force. So here the mainly the student should focus on this simple formula. As you know that force which is equal to pressure into area. So that force can be uh, explained, can be defined as the pressure into area. So pressure in the sense sigma T, that is flow stress or pressure, sigma F flow stress into area. Area means pi by 4 d square. Okay. So general here stress means Newton per mm square, and area is mm square. This will cancel. Finally, you will get force in newtons. So that is why if a student, if you know this formula, it is a very simple one. If you don't know the formula, it is very difficult to attempt to even a simple problem also. Just direct substitution of this problem. Okay, so that is why only a few textbook, few reference books having all these formulas and all. So anyway, I'm going to give some good important formulas also which is related to attempt the competitive examinations like GATE, IAS, etc. So now let us see the first problem. The problem one. Look at this. How we can able to read this problem. How do you solve this problem easily? So using open die forging. In general, forging can be classified into two types. One is the open die, second one is closed die forging machine. Open die in the sense there will be some what you called annual. So there you can kept this, and you can apply pressure with the help of the hammer. Okay, so that changing. This is open die. Open die. So simply with the anvil you can keep the work pieces, and this the hammer should apply the force and pressure in order to change its shape. Open, but in open die forging, it is very difficult to maintain the good dimensional accuracy. So we have to fold properly that workpiece. Otherwise, while hitting the component, it may be changes its position. So suddenly, when you wanted to apply pressure here, it may lift to some distance. Automatically, the uniform pressure and force cannot be maintained in this case. So that is why all the student can able to understand theoretically, the concept of the forging, classification of the forging, how you will perform this forging, what are the advantages and limitations. But when you are discussing the problems, so not only gate examination, any competitive examinations are some simple problems if you know. So here this stress into area directly force, and this bracket some constant parameter, that is 1 plus mu. Mu is the coefficient of friction, d is the diameter, h is the height of the workpiece. So that is the only which has been generated to design of this open die forging operation. So that is what I wanted to explain this. What is this? This is the workpiece component, length, width, height, and what about the force, how much pressure, the flow of pressure should be applied, and what is the area. So as the diameter pi by 4 d square, like that you can able to determine, we can solve this problem. So in this problem, let us see the what is the given data of the problem. First of all, using open die forging operation, a solid cylinder piece of 304 stainless steel. So look at, it is a solid cylindrical piece. So cylinder, this is cylinder, a solid cylindrical piece of 304 stainless steel. It is a core having 100 mm dia. So initial diameter is 100 and 72 is the initial height. So diameter is 100 and height is 72. Initial height and final height is 60 mm. So then when you apply the force and pressure, what will happen? So this height can be reduced. So height can be reduced 72 to this is 60 mm. Okay, the diameter is same 100 mm. So how this cylinder will transfer to the some height reduction 72 mm to 60 mm, how much force is required to change reduce the height. Okay, and obviously the diameter also can be increased. Okay, and look at 100 dia and 72 height is reduced the height of 60 mm at room temperature. Assume that coefficient of friction is mu 0.22 and the flow stress of this material is equal to 1000 MPa megapascal. So 1000 MPa megapascal, and calculate the forging force at the end of the stroke. So how do you determine the forging force at end of the stroke? So the student, only you should remember this simple formula. The force, okay, open die forging, the forging force can be defined so that the stress flow stress into area and some constant parameter, that is why sigma t pi by 4 d square into 1 plus mu d by 3 h. Okay, so this formula we can easily determine the forging force. So what is the given data? Initial diameter is 100 dia and the initial height is 72. Then the height can be reduction by 60, and how to determine that? Automatically the diameter also can be improved. The final dia, how you can calculate. So that is what very important. You can see the how to determine diameter. Okay, so here 100 square. So initial dia is 100 square into, so this is 100 square into 72 is the height. Then what is the diameter to get 60? So the 70 mm height can be reduction to the 60. Then how do you determine the final dia is equal to 100? So 100 square into 72 divided by 60. If you do it automatically, the diameter you will get 110 mm. Diameter you will get 110 mm. So that by applying the force, this 72 height will become 60, 100 will become 110 mm. Okay, of diameter. Diameter can be increased. So like that you can see, this is a cylinder. You can when you apply the force and pressure, this height can be reduction takes place. Height can be reduction, and the diameter also can be enlarged, can be increased. So this is what how much force is required to change it, the shape and position. That is the how the diameter can be increased, that height can be reduction. Then what are the force how much force is required to changes its shape. That's what the concept is, very simple. Okay, but only thing is, if you know the formula, the problem is within 5 minutes you can complete it. If you don't know the formula, so that's what the concept is, the force which is directly proportional to the flow stress into area, some constant parameter like coefficient of friction and diameter of the workpiece, height of the workpiece. Okay, so that is 3 times. Okay, and this as per the design constants, this constant factor 1 plus mu d divided by 3h has been uh, generated with the some case studies and all. Okay, so in this problem, how do you calculate the forging force at the end of the stroke? That is, finally the height 72 will transfer to the 60 mm, the diameter 100 to 110. How it has been distributed effectively, that can be determined. Okay, so first the given data is initial diameter is 100, initial height is 72, final height is 60, and you can determine the final diameter of this area pi by 4 d square into h. Pi by volume is equal to uh, inlet volume to outlet volume, and so that volume is area into this height. So this pi by 4 gets cancelled, so finally d square into this 72 into d square into this height 60. With this simplifying, by simplifying, d is equal to 110 mm, that is 110. We can easily can be obtain the diameter at the end. Okay, and now you are supposed to determine the force, that forging force. Simply you can write the forging force formula, sigma t into pi by 4 d square into 1 plus mu d by 3h. Just you can submission of all these given data. So that F is equal to the flow stress, flow of flow stress is equal to 1000 megapascal. Megapascal 10 power 6 and 1 pascal is equal to 10 power 5 into Newton per mm square. By conversion directly you can use the 1000 into pi by 4. All the units should be in the same. Okay, and the diameter is 110. That final diameter can be achieved is 110 whole square into 1 plus mu is the coefficient of friction 0.2. Mu is equal to 0.22. Yes or no? And diameter 110 by 3 into that 60 is the that final height. So if you use the calculator, can you able to get the total 1078 meganewtons. 1078 meganewton. That much force is required at the end of the stroke to obtain this 100 mm. 100 mm diameter will become 110, and height can be reduction. So the height, total height 72, 72 will be transferred to 60, and the diameter can be enlarged by another 10 mm, so that the radius can be changes 5. Okay, 2 5 is 10. So this is the important formula to discuss and to determine in this forging force. Okay, so that is why students are all some basic manufacturing process also, it is having at the end of that topic, and some formulas will be given. All you student, you make a note that wherever the formulas is available, first you can list out what are the formulas. Concept is simple, the force is equal to stress into area. So like that, similar some simple creative thinking also is required. Some decision making idea should be there. Even if you don't have this constant factor 1 plus mu d by 3 pi. So sometimes they may give some constant parameter also. Without using also you can able to determine sometimes exactly the designed as per the designing of this type of component, that formula to be used. Sometimes if you are not using this also, 50% of the solution is right only. But why I have to add this design specification? In order to height, diameter, and coefficient of friction. By applying the force, compressive force to the component, the friction will be generated. Automatically, this formula is most suitable for finding the forging force. So this is a in 10 years before this type of problem they were asking for 5 marks. Nowadays only 2 marks. Even some competitive examinations, 1 mark also they may give, because directly straight to force is equal to stress into area. In that form also can use a simple 1 mark question also they may ask. But the only thing is we should focus. It is a open die forging operation. It is a solid cylindrical piece of the stainless steel material 304 of specification. Diameter and height 100 into 72 will be transferred to that 60. So the 60 height, and what about its diameter can be increased. Simple thing, volume at initial is equal to volume at the final. You can equate it and you will determine the final diameter. Once you know the final diameter, directly you can substitute this design forging force formula, sigma t into pi by 4 d square into 1 plus mu d divided by 3h. So by substituting all the parameters in this formula and simplifying, we will get that forging force is equal to 1078 meganewtons. So all this problem also is available in Goshen Malik and some Kalpak Jain also. This different type of problems also will be there, but only the numericals will be changes only. So this is what about the important problem is discussed in forging. And every time some new type similar type of problems they may not give in the examination, in competitive examination. Always they will twist the parameter, like you can see the here design parameter 1 plus mu d by 3h. So in that purpose only, a student can able to list out all the formulas which is available in the different variety of textbooks like P and Rao and Goshen Malik and some of the metal casting by Rosenthal. These textbooks are very, very important to having some design type of formulas. We can list out and we can able to substitute the formula values and directly we will get with the calculator, we will get these answers. Okay. So this is what about the how do you determine the forging force for a open die forging operation. I hope the student can understand clearly. Now, look at another important problem in a metal forming or mechanical working of metals. This is what another example you can see this is also a second problem. Let us read a circular blank of 30 diameter, a circular blank. So for example, you can see the inside. This is a circular blank. This 30 diameter, 30 diameter, okay, is to be cut from 2 thick, is to cut from a 2 thick, and this thickness in the sense like this, okay, and 0.1 c steel sheet is the specification. Determine the die and punch sizes. How do you determine the punch and die size? Also estimate the punch force and stripping force is needed. You may assume that the following for the steel tensile strength is 410 megapascal and shear strength is 310 megapascal. Sometimes they'll give directly some important information, data will be given. If it is not given, you should able to refer the some of the design data books also, respective of this specification. Point 1c, stainless steel or some carbon steel, some alloy steels, that material. So certain material automatically, these are some standard tensile strength and shear strength will be 410 MPa and 310 MPa. Okay, so look at the blank. How do you cut the blank? So blanking means punched out part. So this part is coming out of this. This is a blank. So if you do separately, it will form like a hole. It will form like a hole. Okay, so this blank, this is a punched out part is called a blank. This hollow portion is called the piercing or punching. Okay, look at in this problem, how do you solve? So what they have given, die size is given 30 dia. So the die size is 30 and what is the clearance? Clearance is very very important for certain type of material. The clearance formula is, so that is some 0.003 t tau. The clearance can be determined with the help of the simple formula, some L t tau. So some, what is the changes is the L t tau. Okay, and some constant factor, uh, some L, T and tau. Okay, so where T is the thickness, tau is the shear stress, and L is the that constant parameter they may given here. In this case, already you can see the, so the clearance 0.003. So clearance is 0.003. Thickness is, you can see the 2 thick. Thickness is 2 thickness. Tau is the that shear strength, 310 shear strength. If you calculate, you will get the clearance 1.86 is the clearance of the given problem. And similarly, how do you determine the punch size? So obviously punch size means always you have to subtraction with it. Punch size, which is nothing but blank size minus 2 times of clearance. Okay, 2 times, because if it is radius means 2r is the diameter, like that. Here punch size can be determined as blank size minus 2 times of clearance, or blank size is equal to punch size plus 2 times of clearance. So obviously here blank size is given 30 minus 2 times of this clearance 1.86, which is gives rise to 26.28 is the punch size. And now we can determine the, how do you determine the punch force? So the punch force can be determined what you call LT tau. Okay, LT tau, in the sense you can see the so that what you call this die size. Okay, so 310 is the that shear strength. Okay, pi by 4 d square, pi by 4, that some calculation is there. Okay, and finally the punch force is required 58.5 kilonewtons. And similarly, what is the formula for the stripping force? 0.002 what you call some length into thickness. Okay, 0.02 pi into that 30 into 2 will get the 3.77 kilonewtons is the stripping force, and punch force is equal to 58.5 kilonewtons. This is the way you can suppose to determine for the blanking, and how we can able to have the die size, punch size. In general, punch out part, this is a blank, this is piercing, making holes, piercing or punching, making the hollow portions and all. So obviously the what you punch size always will be blank size minus 2 times of clearance. If you want to determine punch size means, so that blank size means punch size plus addition of clearance. Punch size You have to add the additional clearance so that it can be fit properly for this problem. So like these type of problems also they may ask in the examination. Look at another interesting concept here. In a blanking operation, and there are two different type of operation. One is the blanking operation and another one is the piercing operation. So there are two different type of operation. So wherever we have seen the die size which is equal to blank size, where punch size is equal to blank size minus 2 times of clearance. So this formula to be used for blanking. So always uh, in a blanking operation, die size which is equal to a blank size. What are the die size which is equal to the blank size? Wherever punch size is equal to, you have to deduct blank size minus 2 times of clearance. The clearance will be some constant factor T thickness into some tau stress, shear stress. Okay, so this is the formula to calculate the clearance. And similarly, tau is the shear strength of the material, T is the thickness of the sheet metal structure, K is the constant whose value may be taken as this what 0.003. That is why you have taken this the constant parameter which is taken from the some design data book. Sometimes they may give the data. Okay, and here, similarly, if you take the piercing operation, what will happen? Punch size is nothing but blank size. But in the case of blanking operation, die size is nothing but blank size. But piercing operation, punch size equal to blank size. Where you wanted to determine die size means blank size plus 2 times of clearance. That is what very important. Okay, die size. So here punch size, whenever the blanking operation, we are supposed to determine punch size by deducting the 2 times of clearance. When the piercing operation, die size will be, we have to add the clearance, blank size plus 2 times of clearance. That clearance can be determined with the simple formula, some constant factor thickness into a shear strength. This constant factor may be 0.003 as per the standard textbooks, and you can take this constant value, and that value will be important for the material to material. Okay, so this is what about the some simple problems where it is really needed for the some gate examinations and other competitive examination. So I hope the student can understand clearly how do you work out about these type of problems for solving any type of competitive examination. Even sometimes they may ask if you manufacturing process subject, always it will be theory. Suppose any one expert professor in IIT, NIT, they wanted to set the question paper. Obviously, they may give the simple type of problems like what is the die size, how we can determine the clearance, what about the punch size, what about the different type of forces, punch force and stripping force can be calculated. Some constant parameter you can able to determine with the design data book. Okay, so this is what about the some of the gate problems I discussed for the metal forming and mechanical working of metals. So I hope the students can understand clearly about this topic. Okay, thank you.
Like, share, and subscribe. Hit the bell icon for more updates.